Good afternoon, guys. First, want to say thank you for an awesome pep rally. Had a nice little yogurt snack, and special thanks to Miss Randolph and Naomi Coles and Erica Anderson, who are your SGA president and vice president, for an awesome pep rally. Just want to come to you pretty quick about limiting reactants. This concept is very easy to understand if you understood the information from video 5 and 6. So, a limiting reactant is something that's going to run out first. So I have kind of a very crude picture to kind of explain. Let's say we have 5 boxes of corn muffin mix. If we have 5 boxes of corn muffin mix and only 1 egg, an unlimited amount of water, it doesn't really matter how much of the other things we have. The eggs are limited. So really, we can only make 6 corn muffins. So what we're really talking about is what happens when we have different amounts of the reactant. So here's a problem. Freeze it, copy it down, and we'll go from there. The problem says, the reaction between sodium and iron 3 oxide is one of a series of reactions that inflates an automobile airbag. Sodium 100 grams and iron nitrate 100 grams are combined. As a side note, we talked about one of the reactions in the last video with sodium azide. This is a separate one. And the equation is 6 sodiums plus iron 3 nitrate gives you 3 sodium oxides plus 2 irons. So the first question is, what is a limiting reactant? The second question is, what is the excess reactant? And the third question is, what mass of iron is produced? Do me a favor, write the equation at the top. Go ahead and put in the knowns, and you'll have 2 knowns this time. Go ahead at the bottom and put the unknown, and then start to turn the video back on. Okay, so let's talk about what we're going to do. When we solve the corn muffin problem, and if you need to go back to see my little crude picture, what we basically do is, in our head, imagine how many corn muffins we can make. We imagine that with 5 boxes of corn muffins, we can make 30, or 5 boxes of mix, rather, we could make 30 muffins. But 1 egg can only make 6 corn muffins. We look at the 30, we look at the 6, and we choose the one that makes the least. That is our limiting reactant. We're going to do the same thing here. So we're going to solve the problem first for 100 grams of sodium. Then we're going to solve the problem again for 100 grams of iron 3 oxide. We're going to compare those 2 amounts, and the one that is the least is the limiting reactant. The one that is the most is the excess reactant. There are a lot of different ways to do this. I find that for my students, the best way is to solve it. Skip 1 and 2, solve number 3 for both knowns. And then once you get that answer, go back and identify the limiting and the excess. So let's assume for a second that our limiting is the first one, the sodium. We would solve them, we would solve it just like we do the traditional problem, a traditional grams to moles conversion. Oh, sorry, actually a grams to grams conversion. So we would notice that we're going in A to E to A path. We would need our A, our E, and then our A for our unknown. If this doesn't make sense to you at this point, you need to come see me for tutoring, because this is the concept that we've been talking about for the last 2 classes. So you solve it just like you normally would. We have our known here. We put our molar mass here, our molar ratio here, and our molar mass of our unknown here. And we would get 80.977 grams of iron. We now would solve the problem all over again for the second unknown. Same process. Notice that a lot of this looks the same. The major difference is your A and your E, because now we have to calculate the molar mass of the iron 3 oxide, and we have a different mole ratio because we're comparing 2 different substances. Pause, copy what you need to. When we plug into our final problem, we have the 100 grams of iron this time. And actually that should not say iron, that should actually say iron 3 oxide, so Fe2O3. Then we're going to have the molar mass of that substance, the mole ratio of that substance, and the molar mass of our unknown. We solve and we find that there are 69.94 grams of iron produced. The sodium produced about 81 grams. This one produced about 70 grams. Which one is the least? Just like in our corn muffin analogy, it happens that this one is the least. So that changes things. Our limiting reactant is going to be the iron 3 oxide. Our excess reactant is going to be the sodium. And our final answer is the amount of our sodium expressed in significant figures. Now, if you are like me, you really don't want to write all that again. So what you can do is you can go back to your initial problem, and where you wrote if sodium is the limiting reactant, you're just going to put a big X through it because sodium was not the limiting reactant. This will let me know that you did the work to come up with the answer, and it's still neat enough for me to read. However, that information is not your final answer. Then you'll go to your other reaction, the one with the iron 3 oxide, and you will circle the final answer. For those of you who would like a problem to solve, try to solve the problem that is inside the POGIL, the extension problem on the POGIL. It's actually the last problem. I believe it's either problem 15 or 16. We're going to start class with that problem next class. So everybody, whether you do the extra credit assignment, which is the front part of the packet, or not, and you only had to do that packet through question number 10, regardless, I want you to try question number 15. If you can master 15 with no problem, then you are well on your way to an A on the next quiz. See you soon, and enjoy your weekend. Bye.